This video is for October 16th or October 17th. We're looking at right triangle trigonometric applications. So this is an extension of what we did before fall break, looking at sine, cosine, tangent, and how we can apply those to solve like real world situational problems. So for example here, if you want to pause it, read the problem, that might be a good thing. You know, similar to the rice, we talked about R, I, C, E. Reread the problem, indicate any relevant information, and illustrate what's happening, calculate it, and if we can, explain what's happening back in the context of the problem. Here, we have, we're building a wheelchair ramp for an elderly couple. So I'm going to go ahead and draw what's happening. Let's say this is our house. What's happening here is we have a door, a little window here. So that's our house with the door. The ground is here. And the Habitat for Humanity, what they do is they build houses for people who need homes. And they're building, in this case, a wheelchair ramp for an elderly couple. So here they're going to build a ramp. There's our ramp. We know that the distance from the ground to the base of the door is 3.5 feet. So if we're at the ground here and we're going to the base of the door, this would be our 3.5 feet. And the state of Tennessee requires all wheelchair ramps to have an angle of elevation of 5 degrees. Well, if we think about elevation, we're talking about increasing, rising. And so what an angle of elevation is from our horizontal, whatever our horizontal might be, the angle of elevation is telling us how much we're going to increase. So for this problem, our horizontal is going to be the ground here, and as we increase, this is our angle of elevation, and so that would be 5 degrees. And we know, so this is our ramp. I'm going to put ramp here. 3.5 feet from the base of the door to the ground and an angle of elevation of 5 degrees. One more thing we know about this triangle that's really important is that it is a right triangle. So if they build this house correctly, that should be a 90-degree angle. If not, then we're kind of screwed. But we're assuming that they built the house correctly, so that would be a 90-degree angle. So that's taking care of these two pieces here. We read the problem, maybe reread it to make sure we knew all of the relevant information. We indicated that relevant information and illustrated what was happening. In part A, they're asking how much wood does the Habitat for Humanity need to buy for the length of the ramp. So I'm going to redraw the triangle. And if we're talking about how much they need for the length of the ramp, this is our ramp here, so this is going to be our x. We're solving for x here. And in class we talked about some things we knew about right triangles. One student said, well, we know that a squared plus b squared equals c squared, and that's true for any right triangle. So for a right triangle we could use Pythagorean's theorem. We could also use, based off of things we've talked about, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so when we tried to solve this problem for x, what students noticed is, well, we have this angle 5 degrees and 3.5. The 3.5 feet in relation to the 5 degrees is our opposite side. And we're solving for the hypotenuse here. So I have the opposite. I'm solving for the hypotenuse. I can look here. We can't use this per se because we don't know two of the sides. But we could use sine because we have an angle, we have the opposite, and we're looking for the hypotenuse. So we could set something up with sine and say sine of 5 degrees is equal to opposite, which would be 3.5 feet, over the hypotenuse, which is our x. And so now we have an equation where we could solve for x and get x alone. Now, if you have questions about setting that piece up, please feel free to ask me. Email, Remind app, website, in class, whatever. But this is how we would set up the equation using a sign. And now we want to solve for x. A few things first. In this class, on the big challenge exam at the end of the year, you will not have a powerful enough calculator to actually calculate what this is. So we're going to leave sine of 5 as sine of 5. We'll just leave it like that. But we can still solve for x. What we need to do is get x alone. When I had students try to solve this, what a lot of students did is they tried to multiply. Well, let me back up. Because we have an equation, we can do whatever we want as long as we do it to both sides correctly. And what a lot of students did is they multiplied by 3.5. I'm going to leave it as 3.5 over 1. Because I don't have a fraction over here, I'm going to leave it as just 3.5. But let's think about this. If I were to multiply on this side, what's happening is we have 3.5, I'm going to scoot this up, 3.5 over x times 3.5 over 1. If we're multiplying fractions, what you do is you multiply straight across. So this would be like 3.5 squared over x. Nothing divides out. It's not actually helping us eliminate things and solve for x. So we need to be careful here. Don't just multiply or divide and just think it's going to divide out. Actually think about what's happening. And so this is not wrong, multiplying both sides by 3.5. But as we see up here, this, by multiplying each side by 3.5, we're not actually dividing anything out. It's actually not helping us simplify it and get to something where we can get x alone. So instead of multiplying by 3.5, what we can do, I'm going to erase this. Another student said, well, why don't we multiply by x? If x is in our denominator, why don't we multiply both sides by x? I'm going to do another little aside here. Now, if we multiplied this by x, we would have 3.5 over x, x over 1. Multiply straight across, and what would happen here is the x's would actually divide out. So it seems like multiplying by x at least helps us, get rid of a fraction. We could divide these x's out. We would be left with x times sine of 5 degrees over here on the left-hand side. On the right-hand side, we would basically have 3.5 divided by 1, which is just 3.5. But we haven't gotten x alone yet, so we still need to figure out how to get x alone. We have x times sine of 5 degrees. If we want to reverse that multiplication, we can by dividing. Now these would divide out, and what we're left with is x on the left-hand side, and on the right-hand side we would have 3.5 over sine of 5 degrees, which would be our solution for this class. If you're really curious as to what that value is, I believe it's 40.17 feet. So if we had a calculator, we could actually calculate that out and figure out what x is. In this case, we don't have those kind of calculators, so this is how we would leave that solution for right now. If you need to pause, rewind, please do so. Ask as many questions as you need. But the idea is that we can set up a triangle and use one of our either sine, cosine, or tangent, depending on the information that we're given, to actually solve for the other side of the triangle. I'm going to put these definitions up, talk about them briefly, and then do one more problem on the next video. But here are the definitions for angle of elevation and angle of depression. The key thing here is we have a horizontal in each. So we have to have a horizontal and a line of sight. The angle of elevation, we skipped part B, so don't worry about part B. The angle of elevation is if we, similar to what we did in the first problem up there, is if we have a horizontal, then the angle of elevation is going up, and that would be our angle of elevation. I'm just going to write elevation. Similarly, angle of depression is an angle between the horizontal and the line of sight to an object below the horizontal. So if we have a horizontal here, key thing, we have to have a horizontal. So if this is my line of sight, then as I look down, that would be my angle of depression, which is a key thing to notice. We have to have a horizontal first, then look down to create our angle of depression. We're going to see how we can apply this angle of depression in this next problem, and I'll do that in the next video.